In this video, we'll learn how to use advanced technology nodes like 65 nanometer and 180 nanometer in LTSpice. So basically, we'd like to use these advanced technology nodes to do our simulation of the MOSFET in LTSpice. So using those models, we will try to do the IV characterization of the MOSFET. So this is my LTSpice schematic editor. So first we need to get the component. We need to go to component and get the MOSFET. So if you write NMOS, so you can get two kinds of components here, either NMOS or NMOS 4. The difference is that when you select the NMOS 4, your bulk terminal is not connected to the source, whereas when you take NMOS, your bulk terminal will be connected to the source. We'll select NMOS 4 so that we can connect the bulk and the source separately. So this is my NMOS. So now I need to connect a voltage source for generating the VGS and also another voltage source for generating the VDS. So go to again components, type voltage. So you can select here and then click here and click here. So V1 is to generate the VGS and V2 is to generate the VDS. Now of course I need a ground for each of them, so go here and select the ground. Okay, ground here, ground for my source, ground for my bulk, and of course ground for this others V2. So now use the where and just connect the terminals. Okay, so my the terminals are connected. So let's give some voltage here, VGS. Maybe let's start with 0.6 volt. I'll not give any voltage to V2 because I'll be sweeping maybe from 0 to 1.2 volt or 2 volt. Let's see. First thing is I need to import the model. So let's start by importing a 65 nanometer model for this MOSFET M1. To do that, open the Google and type predictive technology model. So if you go to this website, this is an website maintained by the Arizona State University. So here you can get the latest MOS models. So you can get models of 7 nanometer, 10 nanometer and even 16 nanometer. So all these are like predictive models. So these models are quite good, or they are quite close to the models that are available in the foundry. So let's maybe consider the 65 nanometer this model. So to do that, just click here, and of course if I click here, then I can see all the parameters here. So this file has the both NMOS and PMOS models. So these are all the model parameters. Of course I should not be worried about all these numbers. So I need to right click as and save it as download link file as. So this will be saved as .text file. So the file name given is 65 nanometer underscore bulk .text. So this is my folder where I'll be saving it. Save it. Okay, so it's saved. So I have saved this 65 nanometer file. We should also save this LTSpice file, so I'll be saving it in the same folder. So I'll be saving it in the same folder as MOS characterization maybe. So save. So I have saved it as MOS car. So the next is we need to, because the model file is already saved in the save folder, we need to call that, so that whenever I'm doing the simulation, that file is called. So I need to include that file in during the simulation. So to do that, just right click and then spice directive. So just try .inc and the file name was 65nm underscore bulk.txt. So with this, because both the LTSpice file and this file, they are located in the same folder. You can see here both these files are located in the same folder, so I can just write .inc and the file name. If both these files would have been located in other folder, then I would have to give the path for this file name. So okay, so now this is done. So let me set maybe the W of this MOS. So let's set the W and L of this MOS. So let's set the L maybe 100 nano and W maybe 1 micrometer. Okay, so now I need to do a DC sweep analysis so that I can vary this voltage so that I can get the IV characteristics of the MOSFET. So to do that, again right click, go to draft spice directive, and again right click here and help me edit analysis command. So go to DC sweep, and because I'm sweeping V2, right, V2 is the voltage source, right, and I want to start the value from 0 and the stop value will be 1.2 volt, because the maximum value for 65 nanometer is 1.2 volt and the increment can be 0.01 volt, means I'll be changing the value of the voltage by a step size of 10 millivolt. So you can keep it here. So what this command is telling, that it's a DC sweep analysis where I am changing the voltage V2 from 0 to 1.2 volt with a step size of 0.01 volt. Now I think I'm all set here. So run the simulation. So now it will ask me what should I plot. So basically I want to plot this current, right? So if I just hover my pointer and bring it close to this drain terminal and just click here, then you will see that I can see this characteristics, IV characteristics of the MOSFET. So my VDS here is changing from 0 to 1.2 volt, and this is the curve of the current. So now suppose if I want to do maybe I want to see the variation of this curve with the change in the VGS. I can do a simple parametric analysis where maybe I can change this voltage V1 from 0.6 to maybe 0.8. So to do that, first I need to set this as a variable. So let's set this as a variable instead of a fixed value of 0.6. Let's make it a variable, maybe VG in, right? You can give any name, and this could be this should be under this bracket. So the next is we need to add the command so that I can sweep this value of VG in from 0.6 to 0.8. So for that you can go to draft, again spice directive. So I need to use this command step. So basically I am means parameter, so I am doing this changing this parameter VG in from 0.6 to 0.8, maybe with a step size of 0.1. So I can add this command. So basically this is a step. I'm increasing this, I'm doing this parametric analysis where I'm changing this VG in from 0.6 to 0.8 with a step size of 0.1. So if I run the simulation again, so I can see this 3 steps basically. So one is VG in corresponding to 0.6, this is VG in corresponding to 0.7, and this is VG in corresponding to 0.8. So in this way, we can do the simulation of the MOSFET using the 65 nanometer bulb.txt. So if you want any other technology, maybe 180 nanometer, again you can go to the website, you can download the 180 nanometer underscore bulb.txt, and you can do the simulation of the MOSFET using 180 nanometer models.